what we're talking about here is linear transformation. So linear means like it's a y equals mx plus b, just like a line, where we're only talking about multiplication and addition. So there's no squaring of x or square rooting. There's nothing else happening here that would make it quadratic or anything like that. So we're not doing anything to x other than multiplying by a constant and adding a constant. And what we're actually doing is we're doing these operations to every piece of data. So this is for every x sub I, and then we convert every individual piece of data and we have a new data set. It's different. It's been transformed, okay? And I want you to think about this. If I plot people's heights in inches, but then convert to centimeters, what changes would occur? What would stay the same? And you may be thinking to yourself, well, what changes do I even want to think about? And the changes that I want to think about are shape, outliers, center, and spread. I guess context. Does context change? I hope not. Okay. So these are the questions that we want to consider here. Would the shape of my distribution change? If I have a classroom that is skewed right, when I just convert from inches to centimeters, would it all of a sudden be symmetric or skewed left? Would the shape change? If someone was an outlier when we measured them in inches, would they still be an outlier when we measured them in centimeters? If I multiply the inches by 2.2 or whatever it is to, no, that's for kilograms. But if I adjust from inches to centimeters, would the center move? Would the piece of data who is the central point move? Right? So like little questions like that. Would the data be more spread out? Would the spread change? Well, those are the things that we want to think about, okay? Hopefully you have a few of those answers already in your mind. So let's look here. When I add a constant to every piece of data, like if you scale a test score, right? So if this is the average of how people did on a test that I give in AP Stats, and then I'm like, all right, well, let's scale it. So let's add 50 points to everyone's score. What's that going to do to my graph? It's going to shift it to the right. And now that's my distribution. And so what has changed? What hasn't changed? So did the shape of my distribution change via addition? Nope. Did the outlier? So this one didn't have any outliers, but if something was an outlier before, would it still be an outlier now? That's unchanged, okay? The value of the outlier change, right? If you were an outlier way up here because someone had gotten like, because way back when, if someone had gotten like a 35, okay, when I add 50, now they're, or I guess more than 35. If someone was at a 40 or a 50, if there was an outlier up here, when I add 50, they would still be an outlier. They'd have a new value, but they would still be an outlier because they'd still be more than 1.5 IQRs away. Did the center change? Yeah, it added the constant. So whatever constant I added to it, right? So instead of this being, the center being at, back here, the center was at about 10 or 12. When I add 50 to everything, now it's at about 60 or 62, okay? And so everything changes in a very predictable manner, all right? How about the spread? Did my data get more spread out when I added something? Nope, it's unchanged by addition, okay? And so that's what happens when we add a constant, okay? So this is what happens under adding a constant. Okay, and then let's see what happens when we instead multiply a constant. All right, so when you multiply every piece of data by a constant, like when you're converting from inches to centimeters, okay, then what's going to happen is something that's at 0 times any constant, if I multiply by some letter A, some value A, is not going to change. But this 10 is going to get multiplied to 10A, and this 20 is going to be 20A, and this 30 is going to be 30A. So let's pretend like we're multiplying by 2. Then this 35 would have to double, to 70, but the 0 doesn't move. And so what's really going to happen is it's going to stretch out my data, okay? And notice what else has changed. So in addition, this is what happens. Well, let's see what happens when we multiply a constant, okay? So if we multiply by a constant, did the shape change? Did it go from skewed right to skewed left or something like that? No. If something had been an outlier before and I doubled all the values, it still would be an outlier. Okay, so that has not changed. The value of it has changed, but not its status as an outlier. The center, what happened to it? The center doubled, because remember the center earlier was at 12, now it's about 24. Okay, so we multiplied by the constant. Did the spread change? Well, if you think about it beforehand, my range was 35, now my range is 70. And so the spread does get multiplied by the same constant, okay? And so there are predictable things that happen. Notice, addition really only affects the center, okay? It moves your outliers, but it does not change your status as an outlier, all right? Whereas over here, you see that multiplication affects both center and spread, all right? So let's look at one last example, all right? What happens when you multiply every piece of data by a constant? So we're multiplying by A, and then order of operations would say, and then afterwards you add a constant, okay? So if we double everything, then the first thing that happens is it's going to stretch, and it moved my center, okay? So my 12 became a 24, and then if I add, let's just add 20 this time. If I add 20, notice it becomes a 44, okay? So what happens when we do both, all right? When you multiply and add, what happens? Shape, unchanged. Outliers, still outliers. Our center has been multiplied and added. The two different constants. It got multiplied by A and then added B afterwards, okay? The spread only multiplied, okay? And so when you're doing a linear transformation, you need to know what it's going to affect about your data set. It doesn't just blindly affect everything, okay? Last thing I want you to be able to think about with this linear transformations is if you're in doubt, just create this data set, 0, 1, okay? And then, so those are my x's. There's my data set. What would happen if I add 5? It would be 5, 6. What changed? The shape. Well, this is just like two things, pretty simple. Shape hasn't really changed, all right? The outliers. Well, there weren't any outliers. There's still no outliers. The center. Here it's centered at 1/2. Here it's centered at 5.5. Oh, it went up by exactly 5. The spread. This was a range of 1. This is still a range of 1. So addition only added to the center, did not change anything else. What if I multiply by 10? Well, then my numbers would be 0, 10. And when you consider what happens, shape doesn't change, outliers don't change, but center went from 0.5 to 5. Oh, that got multiplied by 10. The spread went from 1 to 10. That got multiplied by 10. And so you know that multiplication affects both center and spread. Addition only affects the center, okay? And so those are the things you need to know about linear transformations. Good luck and farewell.